Just using the turbojet example again, but now this is the most common engine that's used today, the turbofan engine that's used in jet engines or jet aircraft. Your jet airliners obviously use these. As you know, they fly at 30,000 feet, which is 9,000 metres up in the air. They operate at an ambient air pressure of 30 kilopascals quite happily, and they'll operate even less. Why? Because not only is the jet engine working, they use a huge amount of free thrust, which is called bypass air. Those final stage exhaust compressor fans drive the ginormous 2 metre big, 2.5 metre round fans at the front of the engine that suck in a massive amount of air. They just feed it into a cowling going around the jet. At the back of the internal jet engine, there is a massive amount of high velocity air, which is low pressure, which means that bypass air gets sucked in and caught up as low pressure air, or caught up in low pressure, and actually pushed out the back of the engine, sucked out, and it becomes thrust. So this high velocity air just sucks extra air through the engine and just blows it out the back as thrust, without needing to bother about all the extra energy involved in compressing it, burning it, putting it out the back, hitting all the friction, hitting all the problems. So that's free thrust. Just create a low pressure area at the back of the engine due to the high velocity of gas exiting the jet, and it just sucks the air straight through the cowling, throws it out the back. That is absolutely critical to the high fuel efficiency of current jets. They operate up to 90% thrust coming from bypass. It's probably up to about 92, 93, maybe even 94% air. Or 94% of the thrust coming from the bypass going past the jet. That is one of the key points on how jet efficiency has improved and fuel efficiency of aircraft has improved. Talking about engine efficiency and the environmental effect of air transport. Just realised I forgot to mention, as you know, energy is a half times the mass times the velocity squared. By sucking in all that extra air on a turbo fan, we actually produce huge amounts of energy equals the huge amounts of thrust coming out the back of the engine. Something really quickly I forgot to mention on the turbo fans is the design of this front of the engine is critical. What actually happens, that nose cone deflects the airflow up into these blades at such an angle that any dirt and dust and contaminants in the airflow get picked up by the blades and flung outwards by centrifugal force and actually bypass the jet engine. So all the dust goes into the outside cowling as part of the bypass air, and clean air only goes into the engine itself for combustion. There would be nothing worse than clogging up the engine and getting the blades out of balance with dust and dirt. Not to mention that the dust would wear out the engine as well.